All right, we've made it to the end. This is the last problem on the review packet, and this one is from the year that I took the BC Calculus exam. Woohoo! Non-calculator problem because we did not have calculators back then. So we are letting f be the function defined here for all real numbers, and they want to know when f is increasing. So we start by doing the first derivative test. F prime equals, by the product rule, 2x e to the x plus x squared minus 3 e to the x. Then, in order to find out where there are zeros, let's go ahead and factor out the e to the x. We'll have 2x plus x squared minus 3, which more easily put is x squared plus 2x minus 3 in paren. And then we can factor that. We have e to the x times x plus 3, x minus 1, and of course we need this to be equal to 0. So our critical values are going to be where x equals negative 3 and 1, keeping in mind that e to the x can never equal 0. So I'm going to do a number line analysis. Remember that the number line analysis is for you only and does not qualify as a complete answer on the AP exam. So if I plug in some value like negative 4, I'm going to get out positive, negative, negative, so positive. If I plug in 0, I'll get out positive, positive, negative, so negative. If I plug in 2, I get out positive, positive, positive. So the question asked, where is f increasing? And so we say that f increases on the interval from negative infinity to negative 3, union 1 to infinity, and our justification, we always write it because f prime is greater than 0. So that is part A. Part B wants us to find all of the points of inflection, just the x-coordinates. So we're going to start by taking the second derivative of the function. So work on what I had up here. Actually, I think I'm going to work on this version of it. I think it'll be easier if I do that. So f double prime will be the derivative of e to the x, which is itself, times our other factor, plus e to the x times the derivative of the other factor, which is 2x plus 2. Now, once again, I'm going to factor out the e to the x. So I'll have x squared plus 4x plus, oops, excuse me, not plus. I have x squared, need to erase that, rephrase, oops, I have x squared plus 4x minus 1. And I need to know where this is going to be equal to 0. And I'm actually going to have to use the Pythagorean theorem, the quadratic formula, to find the zeros here because that's not factorable. So let's go ahead and do that. I'm going to have negative b plus or minus the square root of b squared minus 4ac all over twice a. So that is going to be negative 4 plus or minus, and I have negative 4 times negative 1, so the square root of 20 over 2, which is negative 4 plus or minus 2 rad 5 all over 2, which simplifies to my final answer of negative 2 plus or minus the square root of 5. Those are the x values of my point of inflection. And actually, what I really should be doing is putting these guys on a number line, negative 2 minus rad 5, negative 2 plus rad 5, and confirming that I do in fact have sign changes. But I believe that I do have sign changes because this is a quadratic and it crosses over the x-axis twice because I have two real zeros of the function. So I'm pretty confident that I have two sign changes, so two x values of the points of inflection. Now, I need to know where my function attains its absolute min, which is either going to happen at a local min or an endpoint. Well, here's the problem. There are no endpoints to this function. The function is continuous across all real numbers. So the only place where I can have an absolute min is at my local min. And my local min is right here at x equals 1, where the derivative goes from negative to positive. So the absolute minimum of the function is going to happen at x equals 1, but they want the x and y coordinates. So I take 1 and I plug it into my original equation, and I get out negative 2 times e. So those are the coordinates of the absolute minimum of this function.